Hi, so today we're going to be talking about probability a little bit, specifically the 7.1 in our homework session. There's a few things that we need to think about when we're talking about probability, and it's mostly vocabulary terms. So, So the first term would be probability in general. So probability is basically the study of how likely things are to occur. We all have like an intuitive sense of this. It's very likely that the sun will rise tomorrow morning, if not pretty much 100%. I mean, obviously we don't know 100%, but we can assume safely that the sun is going to come up tomorrow. Or we know that the probability of winning a lottery is kind of low. And same for being struck by lightning. But when you are asked, like, do you know whether it's more likely to win the lottery or be struck by lightning? A lot of people don't really quantify that in their head. It's kind of hard to say. So another term would be trial. So a trial is basically another word for experiment or test. An outcome is the possible results or the result of a trial. A sample space is a way we describe all of the potential outcomes. So like if you have a standard deck of cards and randomly draw a card, there are 52 outcomes because there are 52 cards. If you flip a coin, there are 2 outcomes. If you roll a standard 6-sided dice, there are 6 outcomes. An event is basically what we're trying to find, I guess. So like rolling a sum of 5 or less than 5 with 2 dice. Classical probability is the number of outcomes of the event divided by the number of outcomes in the sample space. It's sort of like the very specific probability. There's empirical probability, which is the probability calculated by dividing the number of times an event occurs by the total number of times the experiment is performed, where all outcomes are based on an experiment. So empirical probability is sort of like you don't know 100% sure if it is completely representative, because you aren't able to test the whole sample size, but classical probability does let you test the whole sample size. So with this, we can get into some of the examples. A lot of our problems are going to deal with the idea of the fundamental counting principle. And this is the idea, is that if there is, basically if there's P ways to do one thing, and Q ways to do the other thing, that means that there's P times Q outcomes, basically. So in English, that would be, for an example, say you were going to a resort and you could go to, we'll use the example that we used in class, Cozumel, or Jamaica, and there were 3 different hotel suites, like a balcony, and a suite, and a ocean-facing balcony. And we'll just stick with these. If we wanted to know how many different combinations there were, we could just times 2 by 3, I believe, because then you would have C and B, C and S, C and O, J and B, J and S, and J and O. So, and that would equal 6, and 6 is 2 times 3. In that regard, for this first question, we can kind of use that idea. It's asking us to find the probability of obtaining exactly 8 tails when flipping 8 coins. And it wants us to express it as a fraction. When we flip a coin, there are 2 things that can happen. Either you get a heads or you get a tails. There are 2 outcomes to this event. We have 8 coins, and each of them have 2 outcomes. So that would be 2 times 2 times 2, 8 times. It'd be 2 to the 8th. And that will be our answer, except for not quite. That is how many different options there are, which I believe comes out to 256. And then there's only one scenario where 8 tails can happen when you're flipping 8 coins. So your probability is going to be 1 out of 256. This next one is asking us to determine which of the following statements is an example of classical probability. And if you remember, classical probability is the more specific, where it takes the whole, all of the sample size and runs and gets the result based off of that, rather than a test of some of our population. So this one is saying Tom rolls 5 dice 35 times each day for 7 days and records the value of each roll to find the likelihood of rolling 5 dice of the same number in one roll. This feels like empirical probability because it is running experiments rather than like specifically grabbing from the whole sample size, because there really isn't one specifically. This next one is asking us, well, it's telling us, in order to find the percentage of trout he had in his pond this spring, Aaron decided to spend 4 days catching a total of 12 fish every day and counting how many of those were trout. This is also empirical probability, because he is running experiments and he isn't catching every single fish from his pond. This next one is telling us that in order to find the percentage of red cards in a large pile of playing cards, Camilla draws 40 cards and tallies up the number of black and red cards she sees. Let me think about this one. This one would also be empirical probability, because it is saying she's grabbing 40 cards from a large pile of playing cards. We don't know if it's we don't know if her results are going to be exact. They are going to be very close, probably, depending on how many cards there are at least. But this is empirical probability. This next one says that 506 of the 1,500 female students in Heather's freshman class are from her home state. Heather would like to determine the chances of her roommate being from her home state. In this case, this is going to be our classical probability, because we have the exact numbers here. We are able to determine that there are 506 that are from her home state, and if all of those 1,500 female students are able to be a roommate with her, it's likely that 506 out of 1,500 would be the chance. And you could probably simplify that down more. But we aren't running any experiments or anything, any trials, because we already know our numbers, and it's completely representative. You aren't doing a little bit of guesswork. This next one is asking us to identify the sample space, which is all of the elements of a set, listing them all out, sort of like the roster method in our last unit. And it's telling us that an experiment is performed where a 5-color spinner is spun and a 4-sided die is rolled. The possible outcomes for each event are red, blue, yellow, green, and violet for the 5-color spinner, and 1, 2, 3, and 4 for the 4-sided die. Now, we won't go through this whole sample space because that would be very long. But basically, it'd be R1, R2, R3, R3, R4, and so on. You do it with blue 1, blue 2, and that would be it. It's just very tedious, but that is what it's asking for when it's asking for sample space. This one is telling us that a sample of 400 full-time employees found that 81 did not use all of their vacation days last year. However, 95 of those studied expressed a desire for more vacation time. Based on this sample, if a full-time employee is chosen at random, what is the probability that he or she is content with the vacation allowance? This one, questions like these are sort of trying to throw you off. They're giving you a red herring. It is only asking for whether they are content with the vacation allowance. So this 81 out of 400 did not use all of their vacation days last year. This is not relevant. We can toss this out. What we really are interested is the 95 of these, 95 out of 400 that are not content. We are going to take 400 and minus 95, because these people are not content, but we are looking for people who are content. And 400 minus 95 is 305. Whoops. And so that would be our answer, except it wants us to put it in a fraction. So 305 over 400. And that can be simplified. I'm just not going to do that. Which of the following statements is an example of empirical probability? Cody needs to roll 5 dice of the same number to win a game, and he wants to know what his chances are. This seems like it would be empirical probability because it is telling us that he wants to run experiments. But we'll move on just in case there are better answers. This one is saying that 506 of the 1,500 female students in Heather's freshman class are from her home state, and she would like to determine the chances of her roommate being from her home state. This one, as we discussed, is going to be classical probability. This one is saying that Annie is wondering how likely it is the first card drawn from a standard deck of 52 cards will be red. This is also classical probability because we have all of the information and we are examining all of it. We don't need to run experiments. We can determine the probability with the information that we're given. In order to find the percentage of bass, or bass I guess since we're talking about fish, that he had in his pond this spring, Jimmy decided to spend 4 days catching a total of 12 fish each day and counting how many of those were bass. This one also could be empirical probability, so let me think about this for a minute. Okay, I understand. This first one is actually going to be classical probability because you don't need to run any sort of tests to determine the chances of rolling 5 dice of the same number. We're able to think about that mathematically. We don't need to run any trials because we know that a 6-sided dice or any dice, we know the probabilities of all of those dices, like dice, as long as it's a fair dice. You don't need any of those. You don't need to run any trials with that. However, this one with the bass is empirical because we have to figure out how many, what types of fish are even in there in the first place. We're running trials. And it doesn't have all of the information because you can't catch all of the fish in your pond. Well, you probably could, but it's not likely that he's going to. But yeah, that was it. Sorry, it's a very long video, like 13 minutes almost. If you have any questions, please let me know, and I'll answer them as soon as possible.